Hello everyone. Today we will be learning an important algorithm to achieve mutual exclusion in distributed systems, that is Ricart-Agrawala mutual exclusion algorithm. So I welcome you all to our channel Simplified Computer Science Concepts by Professor Rutusha Kadam. So let us begin. So let us start with the illustration of Ricart-Agrawala algorithm. So here there are three processes, process P1, P2 and P3. Now process P3 wants to enter into the critical section. So initially what it will do, it will send a request message to process P2 and P1 which are there in the network. So it sends a request message and with a timestamp, and every process will maintain a queue, and this queue will have two fields, that is, one is the timestamp, TS stands for timestamp, and PID stands for the process ID. So here at timestamp 1, process P3 has made the request to all other processes in the network to access critical section. Now what happens, at the same time process P1 also wants to enter into the critical section. So process P1 also sends the request message to other processes on the network. So it will send request message with the timestamp to process P2 and P3, and it will update its own queue by appending its own timestamp with the earlier timestamp of process P3, and it will update the queue now. So here if you see the queue which is maintained at process P1 has timestamp 1, process ID 3, timestamp 2 and process ID 1. Again at process P2 also it has both the timestamps, but at Q3 there is no timestamp of process itself, so which means it will maintain the timestamp of the other process which is coming, because it knows that it has to access the critical section because it was the first process who had sent the request. Now what happens is that process P2 is not involved anywhere. It is neither it does not want to enter into the critical section, neither it is accessing the critical section. So immediately process P2 sends a reply message to P3 saying that you can go ahead and use the critical section, I am not interested. So it sends a reply message. Similarly, process P2 sends a reply message to P1 saying that I am not using the critical section, you can go ahead and execute the instruction. Now P1 also sends the reply message to process P3. Now again here what happens, why P1 is sending a reply message to P3, because it will check its queue, and the smaller the timestamp has the higher priority. So who has a smaller timestamp? Process 3. That is why process P1 understands that P3 has the highest priority, so it will not get the critical section, so it sends a reply message saying that you can use the critical section to P3. Now what happens here, the requirement to enter into the critical section is that it should receive reply messages from all the other processes. So if let's say P3 wants to enter into the critical section, it has to receive the reply from process P2 and P3. So let us check whether it has received a reply from process P2 and P1. So see, P2 has received a reply from P2 as well as it has received a reply from P1. That means process P3 can enter into the critical section. Now once the critical section has been used by process P3, it will release it. Now when it will release it, it will send a reply message to process P1 saying that I have used the critical section, I am done by using the critical section, now you can use the critical section. So in the earlier Lamport's mutual exclusion, after the critical section was used, we used to send release messages. However, here release messages are not used. It straight away sends a reply message to the deferred request earlier. So which was the deferred request earlier? It was process P1. That is why P3 sends a reply message to P1. And now just check, P1 has received two replies, that is this reply from P3 and this reply from P2, which means that both the replies are received at process P1, which means that it can now enter into the critical section. So now P1 enters into the critical section. After P1 enters into the critical section, the queue of all the three processes is empty, and the critical section is remained with process P1 until some other process wants to access the critical section. So that is all about Ricart-Agrawala mutual exclusion algorithm. So by looking at the example or illustration, just map this concept algorithm to that concept. So if a process wants to enter into the critical section, what it has to do? It has to first send a request message, and after sending the request message, the recipient signs processes will send a reply message. Now, who will send a reply message? So first of all, the process which is not currently executing the critical section will immediately send reply message saying that I am not using the critical section, you can use it. And the second scenario where a reply message is sent is that if the timestamp of that particular process which is requesting is smaller than its own request, then a reply message is sent. Then if a particular process wants to execute the critical section, so what is the requirement? The requirement is that the reply message should be received from all other sites or all other processes that are there in the network. And to release the critical section, we have to just send a reply message to all the deferred requests. So that is all about Ricart-Agrawala mutual exclusion algorithm. Also, we will talk about the performance of Ricart-Agrawala. So here, Ricart-Agrawala's performance, here we can say it is 2n minus 1. What is n? N is number of processes that are involved in the synchronization process. Now, why 2n minus 1? So n minus 1 for request messages and n minus 1 for reply messages. So 1 and 1. So 2n minus 1 for every process which wants to access the critical section, there will be n minus 1 request messages and n minus 1 reply messages. So in our example, we have 3 processes. So 2 request messages and 2 reply messages. So n minus 1, that is 3 minus 1 is 2, and 2 request messages, 2 reply messages. So that's it from my end for Ricart-Agrawala mutual exclusion algorithm. Thank you for watching the video. Please do like, share and subscribe to the channel Simplified Computer Science Concepts by Professor Rutuja. If you have any doubts, please put the doubts in the comment box. Thank you for watching the video.